Hello everybody and welcome to this new section, which is the trigonometric functions chapter. Let's go really quick over what trigonometric functions are about. They help describe a lot of phenomena that relates to triangles. As the Greek word in the roots is tri for three, gonos for sides, and metric for measure, it actually deals with the measurement of three-sided figures, which turn out to be triangles. Not only does it help to deal with triangles, but triangles are closely related with angles. Well, it's Throwback Thursday. Remember when the Earth used to be flat? Good old days, right? Well, the Earth is flat. This one is jumping around. Little did you know, until they fell, that Earth was round. So once Earth became round, the need to be able to explore Earth with different measurements aroused. So they had to use angles. So for example, if you want to go from any point on the globe to another point, you have to go in a little curve, right? So that is an angle that is being formed. Also, if you want to go from here, let's see, maybe somewhere here, you cannot go in a straight line nor take the pathway, right? It needs to be a nice little curve. That is called an arc, and that deals with trigonometric functions as well later on. Also, when you're navigating on water, you don't navigate in a straight path, right? Water, if the globe is a sphere, you navigate in a little arc as well. That is a nautical mile. Trigonometric functions started being useful as calculus also deepened. Also did the applications for it. Really quick one. What angle is formed by the minute hand? You know, when you have the minute hand on the clock. When the minute hand is at 45 minutes, how many degrees is that? When the minute hand is at 50 minutes, how many degrees is that? Have you ever thought of that question? Well, let's see. Trigonometric functions. Any periodic wave can be modeled by a combination of sine functions. What is a periodic wave? Example, sound. The waves of sound travel in a periodic wave. Light travels in a periodic wave. A lot of these natural occurring world phenomena can be modeled using trigonometric functions. More specifically, they can all be modeled using a combination of sine of x. As I mentioned earlier, calculus really started helping the world to see how useful trigonometric functions were. And something to consider when we're dealing with trigonometric functions, they're a little bit different than the standard functions that we are used to. This is a type of transcendental function. It goes beyond, it transcends beyond the basic four operation. When we have a normal function like f of x equals 2x squared minus 3, what are the inputs? Well, the inputs is any real numbers, right? Let me zoom in a little bit more. This is starting to act a little bit weird. The input is all real numbers. Well, what is the output? The output for this one would also be all real numbers. Now, when we're dealing with a trigonometric function, the input, we might still see an x, but this x refers to, this one was reals, this one refers to an angle measure. All right, yeah, we see an x, but that might be a theta for an angle measure. And what is the output? Well, the output gives us another measurement. And the angle can be measured either in degrees or radians. And we're going to be using these ones, and it's really important for students to understand the difference between degrees and radians. If they do not understand the difference, a lot of times when they go to future courses in calculus, they often get confused and their units turn out to be wrong and they get the entire problem wrong. Imagine you're laying flat on a starry night and you see a shooting star passing by and you make a wish upon it. Little do you realize that your wish is dead already, because the light coming out from the star is the light that was reflected thousands of years ago. So for all we know, that light might not even exist. All right, but nonetheless, you still are hopeful, as all we should be, and you make a wish, and the star continues going on. Well, when is that star ever going to come back around the Earth again? That was a question that a lot of our ancestors asked themselves. When they saw celestial movements, they also helped them for their crops. They started counting years. Celestial movements gave rises to a study of astronomy and eclipses and all this stuff. Also, marine travel, that was possible by using the curvature of the Earth and the angle in trigonometric calculations. So, you know, when they cross over the Atlantic, so, you know, when they cross over and they came and they quote unquote discover America, that would not have been possible without trigonometric knowledge. So if you were to ask a wish right now, what wish would that be? But anyway, let's see. Let's start with degrees. Let's understand what is a degree. A degree. So we all know from our geometry courses that a right angle has 90. All right. So a straight angle has straight angle has 180 degrees. It's a straight line. So this straight line has 180 degrees. If we were to cut that pi into tiny half of a pie, right? No, it's actually an entire wait, no. That's where my confusion always came back when I was in high school. I thought of a circle as a pie, but it is not a pie. A circle is total of 2 pi. Ta-da! This is my scream rendition. No. Was it Bango? Who's the one that did the scream? It's in the Art Institute or somewhere. Anyway, let's get back to some math. Let's erase this. Sorry, I went out on a tangent. Let's see. There you go. Let's continue. So we know that a straight angle has 180 degrees. So we were to cut it into just one tiny little piece. All right, that is 1 degree. So every time that your answer deals with degrees and you say, oh, it's 37 degrees, 57.1 degrees, you're referring to the angle formed by the standard position, and if it starts rotating, whatever it ends on its terminal side, this central angle theta is the number of degrees that you have. So 1 degree is a unit of angular measure. All right, we're measuring angles, so we're going to be calling angular measurement. So let's remember, this is very important, that 100 degrees is from here going all the way to the half of the circle. So it's a semicircle, 180 degrees. So when they say they did a 360, all right, well, if a person is facing this way, all right, and a person is really bad and they do a 360-degree rotation, well, they end up being here the same again. So did they really change? No, that should be the person did a whole 180 degree. So that means the person now is facing, if he was facing this way, now he's facing the other way. Ta-da. But anyway, let's continue talking about minutes. So let's see, degrees. Why are degrees really helpful? Because degrees help standardize any type of measurement, and these measurements are really important when you're dealing with this type of curvature and angles. So let's see, let's go into DMS. What is DMS? DMS is degree